over to Paul Olson, who will be moderating our Hot Topics session.
All right, yeah, good. Hot topics. All right, last panel of the day. And Leanne, when I looked at some of the other panels about mid-morning, we had 102 participants. Now we're down to 77. So please, after this, send me the list of everybody who decided not to stay to the end to hear the best panel of the day. Does that sound good?
Yes, I'll do that for you, Paul. I'm sorry. It just, you know, you get to the end of the day and people just start getting tired and they're like, hot topics. I mean, maybe they thought it was about that, the store in the mall, maybe.
Well, thanks for letting me lead up and thanks for letting me close off. Before I jump to this great panel, I want to give a huge shout out to the entire region for offshore wind. We've had George Hagerman, our project scientist, speak to this group less than 2 years ago when it was only an idea. And if you look at what's going on now with the great panelists and about 20 other key leaders behind those great panelists from great organizations, we've really come a super long way in a very short amount of time. And but about 2 years ago, I sat down with George and I said, you know, what do we have to do to move this forward? And I realized we needed a great group of leaders to do this. And not to give a shout out, but one of the best books I've ever read on leadership is Leading Change by John Kotter. And in that, he describes the importance of establishing a guiding coalition, a group of like-minded stakeholders that are as passionate about something as you are. We've had that, we have that, you've heard about from some of them today. And I'm just really surprised that the region has come together nicely and driven on a very aggressive timeline to get steel in the water this quickly. So I have the honor of having Hot Topics, which is what you call a panel with great topics that really don't have anything much to do with each other, except that they're hot. So it's a grab bag. So we're going to be touching on NASA, the Port of Virginia, and HRBT. What do they have in common is they all do mega projects. And if you've known me from my Corps of Engineers time, you know I'm always a sucker for driving mega projects. So I was very happy to take on this panel. Our first panelist is Dr. David Bowles. If that name sounds familiar, it should. NASA has selected him to be the very first man to go to Mars. So David, I know that's news to you. I read it, I got an inside tract on that. So they say getting you there is no problems, getting you back is the issue. Yeah. So pack your spacesuit for that. Seriously, I've known Dave for about 8 years. We were in the federal family together. When I commanded the Corps of Engineer District, he was in charge of NASA's Langley's Research Center. In his new role, he is heading up a brand new organization for Old Dominion University, which is the Virginia Institute for Spaceflight and Autonomy, VISA. But he won't send you an annual bill, okay? He's gonna make us money. And David, I'd love you to talk about VISA. And then given this group of representatives from wonderful businesses out there, now that you're out of NASA and you don't have those constraints, if you could share a couple of your reflections of leading the NASA research, Langley Research Center, and a couple observations that might help the community seize on opportunities, that would be great. So over to you.
Okay. Hey, can everybody hear me okay? Thumbs up. Good. All right. So thank you, Paul. And that's really exciting news about going to Mars. I did not, I must have missed a text somewhere. So I'll start my training tomorrow. I'll do it after happy hour. I won't do my training before happy hour. But if we can go on and put the first slide up there. So first of all, thank you for the introduction, Paul. And it's a pleasure to be with all of y'all today. As Paul said, it's a little something different. But I'll try to tie it to what did they say in one of the videos we saw a little while ago, the pick and shovel business. So I will try to tie some observations to that. So as Paul said, I'll start with my previous background. So I had a 39-year career at NASA Langley over in Hampton, Virginia, one of the shining assets we have in the high-tech industry in the Hampton Roads area. The last 5 years I was there, I was center director. And then 2 or 3 years before that, I was both the associate director and the deputy director. And I will tell you, during my time in the director's office, I had the privilege and really excitement to be involved, as Paul just said, with several mega construction projects and also some demolitions. These were all part of what we called NASA Langley's VITAL program. And it was really a 20-year infrastructure revitalization program to reduce maintenance, reduce the footprint, and reduce operation costs. Footprint, we had a mantra we went by. You know, for every new square foot we built, we tore down 2 square foot of space. So we're reducing that footprint, reducing maintenance costs, and really reducing operating costs with going with LEED certification type thing. So quickly talk about 3 of those projects. Paul was very familiar with one of them. We used the core for the computational research facility. That finished up several years ago. And just a little sidelight on that one, it's called the Katherine Johnson Computational Research Facility. If you're not familiar with the name Katherine Johnson, I urge you to go use your favorite web browser and search engine and search it. She was the leading figure in the Hidden Figures book and movie. She used to work at NASA Langley. We actually overlapped careers for about 5 or 6 years early on in my career. I did not know her then, but a tremendous story. So if you haven't read the book Hidden Figures or seen the movie, I urge you to do so. We lost Katherine about a year ago, but she's been a lifelong resident of the peninsula, and we had her out for both the groundbreaking and the ribbon cutting on that facility. So quite a special moment. Another one that should be finishing up as we speak. I'm not as closely involved with things over there, obviously, as I was, but the Measurement Systems Lab. It will be the largest building on the campus, about 125,000 square feet, if my memory serves me correctly. We're running that one through GSA. We've actually done a lot of construction through GSA. They kind of manage the construction for us. The computational research facility we did with the Corps, as Paul said, and we've done a lot of our demolition projects with the Corps as well. Another one that I'm not going to be involved with, but I'm happy to say I was part of getting funding for it, was our first new wind tunnel in about 60 to 70 years. It's going to be a vertical spin tunnel, and hopefully it's in the budget, and hopefully construction will start on that in 2021. You know, as I get farther into the talk, I will talk about kind of how some of these things tie in to the industries, the pick and shovel business that a lot of y'all are in, and I'll give you some insights and some trends that I see going forward near the end of the talk. But if we can go to the next slide, I'll tell you a little bit about my current job, because it's kind of cool. So let me go here. So as Paul said, I am the first and fairly new executive director of the Virginia Institute for Spaceflight and Autonomy at Old Dominion University. You can see our logo up in the top left there. That was one of the first things we came up with, coming from an organization that had a strong brand recognition. We figured a logo would be a good thing to start with, and we're proud to be part of the Old Dominion University family. You see in the other upper right-hand corner there. So Visa, that's what we call it. I have gotten a few emails from people on campus looking for passport and information and things like that. But it was interesting when I took the job. I said, "Wow, we can call it Visa? Isn't that like trademarked or something?" And they said, "No." So it's all good. So our tagline is igniting growth, talent, and innovation. And as Paul said, this is fairly new. We stood up in October 2019, so about 14 months ago. And as we all know, this has been an interesting past year to start a new enterprise. But I think I'm excited, and I think things are actually going pretty good. We're actually located over on Virginia Eastern Shore, and Visa is going to be the hub to leverage what truly is some world-class assets in space launch, autonomous systems, modeling and sim, and data science, really aimed at solving real-world problems. If you look along the left-hand side there, you see some pictures. The one at the very bottom is a picture of the launch site over at NASA Wallops, run by Virginia Space. Truly a tremendous asset. People don't maybe fully appreciate this. I'm trying to spread the word to everybody I talk to, but right now there's only 4 launch sites in the United States that you can launch all the way to orbit. Lots of people are trying to get into the space business, and I'll talk more about that later, but only 1 of 4 sites right now you can launch all the way to orbit, and one of those is at NASA Wallops, right on the eastern shore of Virginia. In fact, one of their prime customers is Northrop Grumman, which launches cargo missions to the International Space Station right there from Virginia. So that's pretty cool. But we're also involved in autonomy. You see a couple pictures there of autonomous systems, an aerial drone, and a water-based autonomous vehicle. And we think there's some very exciting stuff going on there. A lot of what these autonomous systems do, and satellites that you see in the upper picture there, is collect data. And so what we're very happy, and this is a really exciting project, in partnership with NASA and Analytical Mechanics Associates, a company over in Hampton, we've developed the first US Virginia Open Data Cube. And it's really a place where we're bringing satellite data and other types of data, whether it be ground-based sensors, drones, submersible vehicles, all of that into an open platform and to solve real-world problems. We got funding through the state to stand up what's called the Virginia Small Sat Data Consortium. But this whole data cube concept is really taking that and bringing other data sets. We're working with other universities. I've got a slide I'll show you in a bit. We're also working with the MITRE Corporation, which is housed, corporate headquarters up in Chantilly, Virginia, Northern Virginia. But they do a lot of federal business. They operate a lot of FFRDCs for the federal government, but we're excited to be part of that. And I'll show you some more things we're doing on that in a second. We also took this first year. We had a little seed money, if you will, since I started, since the state runs on a July through June fiscal year. And I didn't start till October. We had a little money left over. So we took that and tried to seed some innovative Virginia-based small businesses. So gave some seed funds out to 3 companies in Virginia, Sentinel Robotic Solutions up in Wallops, doing some air-based over the horizon communications, Universal Solutions Incorporated up in Newport News. They're doing some air-launched UAS work, and they've also, it's been a great way to connect with Fort Eustis and do some educational opportunities. Another company called 8th Continent, they've actually changed their name since we stood up. They're called Scout now, but they do advanced satellite inspection. So we down selected here 2 or 3 months ago to only 2 of those, just based on funding constraints. So we're still doing some work with SRS and USI. We also, as part of the Virginia Small Sat Data Consortium, we partnered with Virginia Space and the launch pad at Wallops, and we've got 2 small sat missions dedicated for the next Northrop Grumman space station cargo launch in probably February of 21. They gave us 2 free rides on that. This is on the 2nd stage, so it's a pretty low orbit. The orbital time lasts for a couple days and then it decays, but it's a great way to check out and do kind of tech demonstration flights. We've also done a lot of student flights with this capability, but we've got 2 of them coming up, one with the United States Coast Guard Academy. They've developed a new sensor to look at oil slicks, which is pretty exciting. So we're going to be flying that, and another kind of communications technology that Virginia Tech, our partner in this, has developed. So that's going on. If you go to the next slide, well, actually, yeah, go to the next slide. There you go. very good. Let me catch up here. So yeah, so things going on here. Hydrodrone, very exciting. So we worked with a small company to help them get a Go Virginia capacity building grant on the Eastern Shore. They've developed a hydrodrone, really looking at bathymetry. So looking at, dredging, they've taken pretty much commercial off-the-shelf components, put them together. So we're excited about that. And the applications, obviously, as you've been hearing all day, the Hampton Roads region is a great maritime ecosystem. So activities that help with dredging and channeling and things like that, we're excited about that. And so we're looking at how we keep that going. Also in the autonomous systems arena, we've partnered with Hampton University, the City of Hampton, National Institute of Aerospace, Longbow, a small company in Virginia, and Old Dominion, and William and Mary to propose an autonomous systems center of excellence, but proposed a grant with Go Virginia for a workforce and economic development program based at Fort Monroe. Fort Monroe has some unique just location qualities. You have access to air and sea, and you're close to some urban areas, but you can get out over the water. So for testing, really how we integrate autonomous systems into public use. So we're excited about that. We're hoping to get the full grant. We got a little revector just couple of weeks ago. We're not going to get the full grant. They asked us to go validate some of the workforce and industry needs with a planning grant. So we hope to have that planning grant awarded early in 21. Last panel you heard was about offshore wind, and we think, and they actually mentioned autonomous systems. We think there's great synergy there. So Paul just mentioned George Hagerman and Jared Cronin, another person who's working in this area. I've partnered with them, and we put in a proposal to the National Offshore Wind R&D Consortium for really, it's multi-state, but really looking at a test bed for certifying turbine-based unmanned inspection, maintenance, repair, and safety systems. We think, again, Hampton Roads is a great location. We think there's actually some work in synergy with NASA Langley Research Center. And so we're very excited about that. One of the other things we're doing is workforce and educational partnerships. One of the charges I was given when I first took this job was to reinvigorate the graduate education program between the NASA Wallops workforce and Old Dominion University. And I think we've been pretty successful in that. Robert Witovich, the dean of the graduate school at Old Dominion, we actually have another info session with the Wallops folks tomorrow morning to talk about graduate classes for spring. So registration is open for that. I think it closes about mid-January. So we're trying to keep that workforce pipeline going. Also work very closely with the community college on the Eastern Shore. Again, trying to get that pipeline between students that might not want a full 4-year degree, might want a certificate. I mean, as I've told people in other talks, and that's not the focus of this talk, but I've given a talk before called "So You Want to Be a Rocket Scientist, so you want to be an aerospace engineer." It takes all kinds of skills. I will tell you. I'm not a rocket scientist. Actually, I'm a materials and structures person, if you want to call it that. I spent the first 15 years of my career doing research on structures and materials. Basically, how do you build spacecraft? What do you build them out of? How are they going to last in space? So, again, lots of opportunities in the aerospace business, and Virginia does have a unique ecosystem, if you will, for that kind of work. Go to the next slide. I want to talk a little bit more about the MITRE activity in the data cube. So if you pull that up. Yeah, so back in January 2020, actually probably one of the last in-person events that I had the opportunity to go to, the MITRE Corporation got all the universities, all the public universities, 4-year universities in the Commonwealth together to talk about, hey, how do we work better together? How do the universities themselves work and partner with each other, and how can MITRE be part of that ecosystem? MITRE does a lot of, they have a lot of research capability on the campus up in Chantilly. And they talked about various tracks. The track I was on is called the MITRE Space Initiative, or UIX. They call it the University Innovation Exchange. And so 4 schools participated in this space UIX. It was Old Dominion, University of Virginia, Virginia Tech, George Mason, and the MITRE Corporation. I don't have on this slide, but I want to give a shout out. Virginia Space Grant Consortium. Mary Sandy and her group is also part of this group. So what we did, we got together in January and said, okay, what's kind of a unifying theme that we can all work on? So with the proliferation of small sats and data, we said, okay, how can we take that and do something for the Commonwealth? This was all about applying these different data sets, and can we solve infrastructure, environmental, and security and public use issues for the Commonwealth by doing this. I brought up the whole data cube concept, so we've kind of rallied around that. We've identified kind of 5 use cases, initial use cases, if you will. Flooding prediction and response, which is near and dear to everybody who lives along the coast here. River health, transportation. If you drive from Hampton Roads up to DC and you go on 64 and 95, transportation could be an issue sometimes. Solar power efficiency. This was an interesting one, looking at how cloud cover might affect how you operate solar fields. And then wildfires. So 4 kind of use cases. We've held workshops over the summer with experts and stakeholders in these 5 areas, understanding what's being done now, what needs to be done, and what are the opportunities of bringing groups together and moving some things forward. Our next steps are going to include formulating some pilot projects. We've already talked to some entities at the state. There is this group called the the Governor's Aerospace Advisory Council. We've actually sit on that, and we've briefed this opportunity to them and the people at CIT, and so hopefully there's some good things we can do there. So I'm probably running low on time, so let's go to the next slide. Paul, you give me the hook if I'm running out of time.
No, I actually just dropped off completely, so I'm back.
Oh, so as far as you know, I'm right on time. All right, that's good.
You get a couple grace minutes.
Okay, very good. All right, so I do want to talk about, and this is really, I don't have a lot of pictures and words here, but trends in aerospace going forward. And I said it's a discussion. Paul kind of touched on it up front. What have I seen in my new job? What did I see in my previous job that relates to a lot of the companies and things we have on the line? So a couple areas. First of all, autonomy, digital transformation, what they call Industry 4.0. Old Dominion's very involved in this. We have the digital shipbuilding activity going on, but this is actually an activity, I called it digital transformation back when I was at NASA Langley about 3 years ago. We started an initiative in this, and it applies to both design and operations, and just an explosion of data, if you will. So let me tell you a little bit about what I see some opportunities there. So first of all, just condition-based maintenance in buildings. We started to go very big into that. So all of our new buildings, all the major heavy equipment in those buildings, we had done numerous studies and looked at the cost savings with condition-based maintenance. So if you can get in and fix something, before it breaks, the cost savings are just huge. And the sensors and the digital technologies and the artificial intelligence, that's really there to make that happen. And it's really what you're hearing now with a lot of work in smart buildings and smart cities. My vision for NASA Langley was to turn it into a smart center. I actually brought somebody up into the director's office to be my lead for transformation, as we started calling it. And the agency liked that so much, they've taken a person and moved her to headquarters, and she's the lead for digital transformation in the agency. So it's nice to see that it caught on. But I was talking earlier about this new building we have going on, the Measurement Systems Lab. I used to go over there and tour while the construction was going on, and this is one of these cases where you all very digital as far as drawings and designs. You could take the iPad, hold it up to the wall, see everything behind the wall. Just really, I think that is the future of the heavy construction business. Excuse me. Data. So I talked about this explosion of data. So in the data cube and just data for planning purposes. Okay, where do you build your new building? You know, if you're dealing with places like NASA Langley or other military installations, and if you happen to be in a coastal region that's prone maybe to flooding, you know, we heavily use that back at the center for planning our new building. Like I said, we were shrinking the footprint and pretty much everything was coming to high ground on the center. I know NASA Langley Air Force Base is doing the same things. They were great partners. We shared a fence line with the NASA Air Force Base yeah, Langley Air Force Base, and it was just great partnership. But I think you're going to see more and more of these digital tools, smart buildings, and the data about where you build them. I see that as a trend going forward. And then just autonomous systems for both inspection and maintenance. I just talked about and other people talked about it in the offshore wind industry. You've seen that. You're going to see it more in the maritime industry. In fact, Huntington Ingalls has just set up a new center of excellence, or will be setting it up. They got the land, city of Hampton. They're going to be setting up a new center here starting in 2021, just in Hampton. And we've already reached out and talked to the Huntington Ingalls folks. That's going to be very exciting. It's a submersible underwater vehicle, and it's going to be really exciting. So I think, you know, just trends both in the autonomy area and digital transformation. I think if the people on this call think about how that applies to them, that's a trend going forward. Now, way out, for those of you like me who are going to Mars, maybe sooner than you planned. Space. So two things I want to say about space. First of all, it's the democratization of space. Space is really open to almost everyone there. If you look 10 years ago, or even 5 or 6 years ago, only a very few companies there. There's a proliferation of companies, so many new players, so many low-cost launch opportunities. And so I think that's really opening up. So I'd keep an eye on that. And if you really want to talk about it, it's really living, working, and building in space, off planet, whether it be in orbit, on the moon, or Mars. So you just think about the challenges, though, to the pick and shovel business, working, say, on a remote planet, but you need all the same things. You need mining, you need that in situ resource utilization, you need habitats, you need transportation systems. So it's all of those things, same things. And with space opening up to more and more people, I'm one of those firm believers that yes, maybe, maybe in my lifetime, that we will be having permanent presence off this planet Earth, starting with the moon and then going on to Mars. So that's for the little farther out planning. I think there are going to be tremendous opportunities there. So with that, I'll just kind of open it up for questions, and we can do questions at the end. Paul, I will say, and go to visa@odu.org. I should have had that on the slide. Just all one word, VISAATODU.org. That has all of our contact information and things like that. And maybe if I can figure out how to post that in the chat box, I will. So with that, I'm done.
Thanks, Dave. That was great. And yeah, I want you to know I gave up my seat so you could go to Mars. That's
okay. Well, I appreciate it.
That's what the type of guy I am.
Okay.
So our next speaker needs no introduction, because that's good, because I've never met her before, and I'm the worst moderator ever and didn't get a chance to talk to her beforehand. So my apologies. So Martha Gross, how do you do? My name is Paul Olson. I'm your moderator. I should have reached out to you last week, but I didn't, because I'm the worst moderator ever. But there's a lot of good stuff about you. First of all, you're a professional engineer, and we love that in SAME. Second of all, you're leading a hot topic right now, which is the technical director for the tunnels and marine work for the 3.8 billion, that's with a B, guys, Hampton Roads Bridge Tunnel, or HRBT expansion. I'm glad you know what you're doing, because I see you've done over $9 billion of bridge work in the past, including the Cooper River Bridge in South Carolina and the famous Tappan Zee Bridge in New York, where I've sat in traffic many a times. So it's a pretty bridge, and I got to admire it. So the question for me is, you've done 2 bridges. What do you know about tunnels? I hope you know something about, because we're only half a bridge, the rest is a tunnel. So with all seriousness, graduate of Virginia Tech in engineering, appreciate that too. Martha, I have not seen your slides. I hope it's not spoken word poetry. And I hope you're going to give us an update on your HRBT project. Thanks.
That's indeed it. Thank you, Paul. And we're going from spaceflight, not to the surface of the Earth, but now we're going under the Earth. So you were right when you said that your panel covers a wide range of themes, both geographically as well as topically. And we'll look forward to sharing a little bit today about the solution coming up for the region's favorite choke point that everyone loves to hate, the Hampton Roads Bridge Tunnel. So if Leanne, if you could put up the slides, we'll step through a little bit about where we are now, some of the novelties that, if we can go back a couple slides to the opening that lead up to this, and then we'll probe into where the project is now, the partners who are helping us deliver it, and then what we can look forward to when this is all wrapped up. So diving then ahead to the next slide gives us a little overview of the area and why we in Hampton Roads have all these water crossings. Any other region would have signature bridges here. Think Savannah, think Charleston, with the grand cable stay bridges perhaps over the harbor. We love our tunnels here in Hampton Roads, and in fact we have 10 tubes throughout the area. We've taken the liberty of highlighting them here just to show how much they influence and shape our travel existence. Many of us have waited in traffic quite a while at many or most of these crossings. And what we want to do is focus today on that one right there in the middle, Hampton Roads Bridge Tunnel. Its first tube was built in '57, second one '76, and explain how we're going to add not 1, but 2 more tubes to expand that choke point and look to the future. So with that, we'll go to the next slide. And we'll look at a little bit of history of how this project is going to be different from those other 10 tubes we just looked at. Our soil here is very, very soft. There's no bedrock for thousands of feet down, so we can't use the tried and true, say, rock tunneling methods you might see in New York or some of the big metropolitan areas. But what worked for us for decades in Hampton Roads was the immersed tube tunneling approach, where a trench was dredged along the path of the crossing. Tunnel segments, whether steel, as for most of the crossings in the area, or concrete, such as we see here for our 2016 Midtown Tunnel, were then lowered into the trench. The segments were joined up with watertight seals or gaskets, and then the whole thing was covered up with armor stone or rock fill. So that had worked well, but there's a new kid on the block, a new tunneling method that now has become feasible in our area. If we look at the next slide, we see that different technology has now become feasible with these soft soils. The tunnel boring machine, and many of these have been built in the US as utility tunnels or subway tunnels with, say, 10, 15, 20-foot diameters. Highway tunnels have now come into play with 30 or 40-foot plus diameters, and this technology is now feasible in soft ground. So one of our questions in developing this new crossing was, which method? How are we going to figure out how next to get across the Hampton Roads? Let's look at the next slide for a clue of what helped us figure out what some of the constraints might be. I like history, so I've taken the liberty of going back to the 1950s. This is a historic photograph from when the first HRBT was being built. You can see there's only 1 tube in view there. And if you look at the center left of the picture, we have the Virginia Department of Highways ferries, those 2 larger vessels traversing back and forth, which was the only way to get across the Hampton Roads back before we had this fixed crossing, the Hampton Roads Bridge Tunnel. Leanne, if you would please click 1 more time, I'm going to show up something on this slide which came into play in helping us understand why immersed tube tunneling can be a challenge. Every single one of those red dots that I've circled there is some kind of boat or ship or vessel Obviously, we have a very busy shipping channel here. Not only the smaller craft that we see primarily here, we have a naval vessel there at the left. We have, of course, the commercial traffic also going through this crossing. And one of the challenges of building an immersed tube tunnel is it sets a lot of floating construction equipment right in the middle of that channel, both for the dredging, for the screeding or the smoothing out of the bottom of that dredged crossing, for the precision setting of those tunnel segments, as well as for the stone fill that goes on top of an immersed tube. So as we were developing this project and reaching out to the regional stakeholders, the maritime community expressed a bit of concern about what this would mean for potentially blocking or interfering with the ship traffic across this across the channel here. So one of the advantages of bored tunneling, though, is once that tunnel boring machine goes underground, it can be steered both horizontally and vertically so that it follows its path and then comes back up on the other island without needing to interfere with marine traffic at all. So that was one of the leading considerations that helped shape this procurement, and in fact, the proposer's interest in saying, with the advances in technology, this project can now be a bored tunnel. So with that, we'll go to the next slide and to share a little bit about what that means for our project. We didn't just unilaterally decide at VDOT that it had to be a bored tunnel. We asked the experts in the construction contracting community, what were their skill sets? What could they do best? And both proposers brought us the bored tunnel approach. What does that look like in terms of scale, recognizing we need to fit two 12-foot lanes of traffic with shoulders, 16.5 foot of vertical clearance, plus the egress corridor for pedestrians to leave the tunnel in emergency. Let's click one more time to understand the scale of what that is. For this crossing, that's a 46-foot diameter machine. And here I've laid that, photoshopped it next to the project's co-located office building. The building is 55 feet tall. If we were able to construct that machine right alongside the office, it would be peeking in the window just behind me. That's how tall it is. If we click one more time, we understand a little bit of whimsy that also goes along with this. As any good piece of machinery needs a name, TBMs, tunnel boring machines, are no exception. So we actually are in the process right now of reviewing entries from middle school students throughout Hampton Roads to help us select the name for this machine once it is finished construction, finished fabrication, and delivered to Hampton Roads. We look at some of the other names of other TBMs that have been built in the US tunnels. And so we're eager to see what the new name will be for our friend there. So with that, that's a little snapshot of how it will be built, but I've leaped ahead of myself. Let's click one more time to understand what is exactly the HRBT project. The project scope, if we click one more time, is not just the tunnel, even though that's fun to talk about, but it's really a team effort of a lot of different components of work. To give you some context of the time frame as well as the team partners that are helping this happen, we awarded the contract about 1.5 years ago, and the scheduled completion is 5 years from now. The design builder, the contractor partner, is a joint venture of nationally and internationally experienced firms who have a lot of tunnel building experience in their background. And then the design partners likewise are very seasoned with landside as well as marine and tunneling works. We talk about the project value being 3.8 billion. I should clarify the design build contract itself makes up 3.3 billion of that, leading to the numbers that Paul mentioned earlier. What's really neat about this, and I want to point out the project funding line, is 92% of this project is coming from regional taxes. So that's the surcharge, the 0.7% surcharge on the Hampton Road sales tax, as well as some of the surcharge on fuel taxes, is making up that 92%. So that really gives the region something to be very proud of. And then the remaining 8% is from state and federal funds. I mentioned that final bullet. The whole project is 10 miles long. The water crossing, what we see in the picture there, is about 3.5 miles of that. So let's click the next slide and understand a little bit more about the overall project scope. Here we see the project from stem to stern, roughly 10 miles, expanding I-64 from the Mallory Street Bridge near Settlers Landing in Hampton, advancing across the water where the blue lines indicate new bridges. The existing bridges that you know and love, those will be removed. New structures will be put in place. So that will mean some very careful traffic phasing and planning to ensure that 2 lanes of traffic can continue in all directions, at all times in both directions. We see the tunnel, of course, that red line in the middle. We'll talk a little bit more about that. And then as we continue toward the right across this picture, we see the project scope in Norfolk, where the existing interstate is being widened from 4 lanes to 6 lanes. That's 6 full-time lanes, but actually will make the left shoulder wide enough so it can be used as a part-time or a peak hour lane when the traffic is heaviest. That'll continue across the Willoughby Bay, through the Fourth View interchange, across Bay Avenue, Ostis Creek, down to the 564 interchange, where it will tie back in with the existing network. So let's go ahead to the next slide and say a little bit more of what this means. If we put the project in numbers, from an engineering standpoint, it's neat to quantify what does this mean from concrete or steel or stone. But also what this slide shows us is we have some very disparate types of work that are blended together in one project. And one of the questions we faced in putting this project together was, should we procure the tunnel separately, then get a bridge contract and a roadway contract, and yes, even an island building contract, because that North Island right now needs to be expanded in order to be large enough to for the tunnel to come up and exit there. South Island is larger, doesn't need that much expansion. And we realized that given the focus of keeping Virginia moving, keeping that traffic moving throughout the corridor, the interfaces among those contracts would be so sticky if they were delivered by separate contractors that it wouldn't serve the purpose of keeping traffic flowing throughout these 5 years of construction. That's why we decided to have a single contractor procure and coordinate the entire project. So going on to the next slide, we'll see a little bit of detail of what that means. Here we see the current view of the islands. I mentioned that the South Island is a bit larger than the North Island. This was an artifact from the 1970s construction, or the expansion, when the soil below the South Island was found to be soft enough that it had to be built extra size to carry a surcharge mound or some additional soil to help those soft soils compress. The North Island has better soil, so it would be able to be built to the final size. That's why the North Island will need to be expanded toward the left. And we'll see some pictures later on of current construction showing marine floating equipment sitting out there and helping that expansion happen. The tunnel itself, if we look at the South Island, is where the TBM is going to arrive next fall. And in that area we see just off to the left, that's where the pit is going to be constructed to set the TBM in when it arrives, and then it will bore upward or northward relative to this photo, and then meet up after about a 1-year trip with the North Island, turn around, and then make its second trip back down to the south. So we'll end up with 2 of those 46-foot tunnels, each of which will contain 2 lanes of traffic. The existing eastbound tunnel will be converted to westbound, so that the 4 lanes you see there will all be westbound lanes at the end of the project. And then the 2 new tubes, 2 lanes each, will then carry all the eastbound traffic. Let's look at the next slide. Here we see just a close-up view of what this means for the North Island. One doesn't pay much attention to the islands when driving across them, but this shows how it will approximately double in size. And from a driver's standpoint, this will just give you some interesting things to watch. Hopefully not while you're stuck in traffic, but the equipment and machinery that will be there constructing this will take a bit of time to first put a rock perimeter around the edge, and then fill it with sand fill to bring it up to the same level as the existing island. We'll look at the South Island on the next picture, and we'll see how not only there's not as much expansion that needs to be done there due to the size of the island, but what I want to point out here is that orange square, or that tricell in the lower middle, that's where this adventure is all going to start. That tricell is the shaft or the hole into which we're going to lower the TBM and where it will start its journey. And then when the project is done, we'll construct the new ventilation building right on top of that to be able to make good use of the space. So that gives us a little bit of orientation of how the landscape is going to change in the area. Let's look at the next slide, and we'll see some more elements of the project. People ask us a lot of questions about the tunnel boring machine, so I thought I'd clip in a few pictures of this machine being built. This is at the factory in Germany, when we conducted a virtual factory tour just this fall to understand what's the status of our machine being built, how is it coming along. And these are some of the indicators of the scale that we're looking at to show the scope of what's included. On the right hand, I've shown a rock crusher. We don't expect to encounter much rock, but the machine is being designed carefully enough to take care of that eventuality. And these hydraulic jaws will deal with any stones that are encountered as the machine takes its path across the harbor. I want to note also in the title of this slide, I've put in quote marks S1244. That's because we don't have the real name yet. This manufacturer, this is the 1,244th specialty TBM that they've built. So we're very pleased with their level of experience in being able to deliver these types of complex machines. Next slide, please. And this again gives us a feel for the scale. Although the manufacturer builds many of their TBMs inside a warehouse, this one is large enough that it'll be built in their outdoor facility, giving us a good view as the process moves along of the size and scope of this coming together. As I mentioned, it's slated for completion middle of next year and delivery to Hampton Roads by ship in fall 2021. Next slide. Everybody's featured Old Dominion University on their slides so far, and I didn't want to be any exception. So here, if we look at the scale of the machine relative to the ODU football field, we see that the TBM, the tunnel boring machine, once we take all its supporting equipment into account, actually is even longer than the football field. And it won't obviously fit in the shaft all in one piece, so it'll be constructed segmentally. What does all that trailing gear do? That carries the ventilation, the electrical systems, the machinery that erects the concrete shell around the exterior of the tunnel in order for it to inch ahead like an inchworm and build its structural shape behind it as it goes. So we're excited to see that all come together and impressed by its size. Next slide, please. I mentioned earlier on that this machine would turn on a turntable once it gets to the North Island. This is similar to the approach at the Port of Miami tunnel, which also built twin tubes with one machine, turned it at the midpoint, and then came back. Each of these trips will take about 1 year. The turntable will be 4 to 6 months in order to disassemble parts of the machine and reassemble them to come back. Currently, the schedule has the machine re-arriving on the South Island in 2024. And then it'll take another year to do the fit out inside the tunnel, where we install the lighting, the ventilation, the fireproofing finishes, the communication systems, and all the other scope that goes inside the tube to make it the facility that the region can enjoy. So with that, one more slide, or a few more slides, and we'll look at the view of where we are today. It wouldn't be a project without the team effort of recognizing all the partners that are helping this go forward. I mentioned some of the larger partners earlier on with our joint venture team, but we also want to point out the contributions of the smaller businesses, the disadvantaged businesses who are helping this move forward. And since these numbers were taken in late November, we've actually moved ahead with a number of DBE and SWAM agreements, as well as the size of contract awards to these small firms. Really wanting to emphasize there's a lot of business opportunities for regional and state firms in helping this project become a reality. We're also proud of the workforce participation achievements, as well as the mission with the on-the-job training program to leave the region's workforce even stronger than we found it by bringing these trainees through the program to enhance their skill sets. Next slide, please. It shows us a little bit in text of where we are with the construction status. The project has been segmented into 4 pieces that are running essentially as 4 separate projects in parallel. And the tunnels are run by one team, Marine Bridges and Island, Hampton Highway, Norfolk Highway. So the coordination effort involves looking over all those parts of the project in parallel. I mentioned the work on the South Island was the first to get out of the gate. That's because it's on the project's critical path, so we started even before the notice to proceed in order to get that critical area, that aspect of the work moving forward. The North Island expansion just started. We'll see a photo in a moment of that work taking place. And we started putting the test piles for the new bridges across the water last month as well. And for those of you who drive back and forth on the Norfolk side of I-64, you'll see landside highway work beginning in early 2021 along that corridor as well. So now for the fun part, the pictures. Let's take a look at what this looks like in its current shape with the next slide. Here's what the South Island looks like now. You remember the aerial we saw earlier, where that left side of the island was just an empty field. Now it's a beehive of activity. You see a lot of equipment there, a lot of action taking place. But on the right-hand side, I've put in a photo of one of our very valuable team members. Yes, that's right, that's a border collie there, because the South Island, in that field that was there previously, had become a preferred nesting ground for a number of birds as they would migrate here in the spring before they flew off in the winter, in the fall. And this wasn't a safe place, as you can see from the amount of construction activity, for that to coexist with the construction work. However, as we see in the upper part of the photo, Fort Wool was a very quiet, a very safe place for the birds to be. So the border collies were able to encourage the birds humanely to say, there's a safe area nearby. This is where you can go and have a undisturbed nesting season. And that worked out very well. This was the first year in 2020 that we had the construction work and the border collies present. And we look forward to continuing that in future years to ensure that the nesting birds are well protected. Moving ahead to the next slide, we then see some of the additional progress on the project. This is a view of the South Island from the water. Previously, we saw it from above. This gives us also a snapshot of just how much and how many different types of operations are taking place with the excavation, with the concrete placement, with the placement of materials, even before the tunnel boring starts. The next view we'll see is some of the marine work. If we look at the next slide, this will show us what the project looks like on the North Island. The craft that you see on the left-hand side are not only in the upper part of the picture, the test piles, but on the left-hand side there you can see the early work for the island expansion, where that doubling of the footprint is going to take place. So this is the view today. If you drive through, you'll get to see something very similar as this action continues to advance. Next slide, please. With that, one final view of the progress at the South Island. Happy to take questions during the question period and look forward to being able to present this project to you in the coming years to advance travel across the harbor. Thank you.
Hey, Martha, that was great. And for the engineers out there, if you don't have a question off of that brief, you need to get your pulse checked, because so many fascinating things going on down there. And so put your questions in the comments for David and Martha, and we'll get to those after we hear from Zach Canody, another great engineer in Hampton Roads, but not under the water, not in outer space, but on the sea and around the port. Okay, Zach, I see you're coming on. Okay, here's the deal. Ready, Zach? The sea is rising. The land is sinking. The ships are getting bigger. The cranes are getting undersized all the time. The offshore wind components are too heavy for the bearing loads of a lot of your terminals. Your channels need dredging. We already contacted Wonder Woman and Superman, and they checked out of the net, because you know what they need? They need a real engineer for this. And that's what you are, and that's what you do. So he's in charge of a myriad of engineering for the Port of Virginia. You can read it in the bio. If it has to do with engineering, Zach is covering it. But Zach, I just have one question for you before I turn it over to you. I see we got Bowles as Virginia Tech and Gross as Virginia Tech. Are you a Virginia Tech grad as well? And is it a conspiracy?
Well, I kind of didn't put that in the bio because I thought that it was implied that for hot topics, you have to be a Virginia Tech guy. And it most certainly is a conspiracy. That I can assure you of.
Well, that takes guts in ODU territory, and I like guts. So, Zach, what I'm hoping for, and I saw your slides, they look great already. Give us that view of port modernization of Hampton Roads. And then if you didn't get my question I sent to you, we do, like the Corps of Engineers, NOAA, NASA, everybody does sort of an industry day to promote our RFPs and projects coming out to the A&E firms and the engineering firms. I've heard that the Port of Virginia does the same thing, and I would love some information to share for the group of business developers and project managers online. Zach, over to you.
Thank you. I'll hit on that at the last slide, and that way it's fresh on everyone's mind as they depart. If you wouldn't mind to pull up the PowerPoint, it'd be fantastic. And so I've got quite a few slides. I typically go through the first several of these fairly quickly and kind of get the meat of the presentation. So apologize in advance, but go ahead and advance the slides here. So this slide here, just a quick agenda for you. Tell you a little bit about the port, what we're doing, and what's coming next. We'll go on and advance to the third slide for briefing on the objectives of the presentation. Kind of assume you guys do PDHs for this, so I wanted to get the objectives out here right away. So just going to kind of gain an understanding, learn a little bit about our ports, talk about some major projects underway, and then hit on that project opportunity item you mentioned. Next slide. So the Port of Virginia is a gateway for global commerce. We have regular ship services from 18 weekly calls from Asia, 12 from Europe, regular service to over 45 countries, and have over 5 first-ins or 5 last outs. And what those are, it's the first place a vessel stops on their journey up and down the East Coast, or the last place they go. And that's important when considering the Virginia advantage of our draft and channel widths. Next slide. So specifically about our terminals, we have 4 terminals here in Hampton Roads, Virginia International Gateway, Norfolk International Terminals, Newport News, and Portsmouth Marine Terminals. I know we've heard a lot about Portsmouth in a couple of the videos today. We also have 2 inland facilities, one in Richmond. That's a barge service that has multiple services each week directly to Richmond. And then we have an inland port in Front Royal called the Virginia Inland Port. And this is really a rail service, and it's intended to help get cargo to and from the hinterlands. Next slide. So what makes the Port of Virginia very unique is that we have excellent connection to 2 major rail services, Norfolk Southern and CSX. That rail network is very important, helps drive our business. And so when Norfolk Southern invested in the Heartland Corridor and opened that up to double stack trains in 2010, it really made us the primary point of location for cargo owners to send cargo through our ports to the Midwest. And so you can see in the slide that kind of connection that we have. We can get to these places in less than 3 days, while a lot of other ports have trouble getting out there. Next slide. And so when we talk about what we are, we're really positioned to move the country's cargo. We have a relatively small primary population that we serve when compared to New York, New Jersey, that light green that you see on the screen. We're serving about 14 million people close to our ports exactly. In New York, New Jersey serves over 45 million. So that discretionary cargo, which is in that light or that dark navy, is what really positions us to serve the heartland. And so our market reach is still competitive in the size of New York, New Jersey, even though we don't have that direct service or direct population that we serve. And so 3 ports on the East Coast kind of all are in that same grouping. It's Savannah, New York, New Jersey, and of course the Port of Virginia. Next slide. So we've been very busy over the past 5 years. It's been a market change in our landside infrastructure. We've completed 2 major projects, the Virginia International Gateway Phase 2 expansion and the NIT optimization project, which implemented automatic stacking cranes, yard densification features, and really removed some of those landside boundaries that we were having to capacity growth. In addition to that, we're investing in the 55-foot deepening project in partnership with the Army Corps of Engineers. We've got some optimization projects for our central rail yard expansion underway, and we recently were awarded a grant for the inland port to double the rail capacity there. Next slide. So hitting kind of the high points of the expansion projects, Virginia International Gateway, we completed this in May 2019, doubled the capacity of containers there, had an expanded rail operation, which is probably the most interesting piece, at least for us engineers on this project. We did extend the berth a little bit, expanded our truck gates, and of course added those 4 ship-to-shore cranes that you've seen in some videos today as well. So I'd like to talk a little bit more specifically about the rail yard and what makes it unique. Next slide. So the rail yard, we added over 8,000 linear feet of on-dock rail. What's special about this is that it's served by 4 new cantilevered rail-mounted gantry cranes that we call CRMGs. Those CRMGs have a rotating trolley, which will take a box that's perpendicular to the rail, lift it up, set it onto a rail car that's parallel to it, and it does it somewhat automatically. What's unique about this is that it allows us to decouple our operations. So a shuttle truck can now take a box from the vessel to a northern container stack. The container stack can now move it to a staging area where a yard tractor would then take it to a landside transfer zone, or from the landside transfer zone to a rail transfer area and then into the rail stacks. So what that does is it allows for much denser stacking of the boxes in the transfer zones, and it decouples the operation. So the bomb carts or the yard hustlers can be left in the transfer zones without a driver present, and it allows that CRMG to really load and unload boxes quicker than the road movement, and it can even be done at night or in periods of lower activity. So it ends up having the benefit of a quicker and more efficient operation. Those CRMGs are semi-automated. They have a hoist and trolley that moves between the areas without an operator being involved with it. However, when it is landed or picked up, the operator does take control and lands that. It's both for safety as well as for precision. Another important part about this project is we created a rail portal for the Customs and Border Protection requirements, so the boxes that go to the rail yard are always scanned for radiation or some of those things that you maybe hear about. Next slide. This project was completed. We, of course, had some design challenges throughout it. It candidly is nothing compared to what the HRBT folks are going to be dealing with keeping traffic moving during their project, but we did have a functioning rail yard that we could not slip on our capacity during the project. So maintaining that pre-construction capacity was a requirement for it. So what we did is we built 2 bundles. The southern bundle was first built and was built in a greenfield area. And then once it was operational and able to be turned over to ops, we then constructed additional tracks on the northern bundle. So reconfiguration of the rail tracks to suit the cranes and crane rails was also problematic in the design. Because crane rails have to be dead on straight. They cannot deviate from their spans at all for obvious reasons. So finding a way to optimize the geometry of the rail coming into the rail yard was part of the design, and thankfully we were able to make it work. Alignment of those rail tracks and turnouts, of course, were another part of that. The crane rail design is always interesting, especially for this equipment. So when the project was fast moving in the sense that we had a deadline. So we did not have the exact equipment specifications completed while we were performing the design. And so during the design, we didn't have the detailed loads for the cranes, and we had to use conservative tie spacings to allow for increased loads. If we thought it was going to be heavier than it ended up coming in, we didn't want to go the other way around and have to go and add rail ties. That was something we went into the project with, and fortunately we're able to reduce the tie spacings and realize some cost savings once the final loads were obtained. The continuous crane rail has a midpoint located between either end for crossing and yard access. And this was a little difficult because you have to have, since they're electrically driven cranes, you have to have a cable trench and panzer belt that has continuous electrical feeds over that. And so the design of that crane rail grade crossing with the Panzer belt that would have trucks driving over it quite often during the day, was definitely a challenge. Next slide. Thankfully, construction went off pretty well. We had no time for rework, and so we took some at the time, I thought some good measures in taking drone imagery fairly frequently to help identify if something was out of place. So maintaining that pre-construction capacity was critical, and say if contractor put a manhole in the wrong spot, you were able to quickly identify that with the drone imagery overlaid with CAD and say, hey, wait a minute, this thing's about 6 feet in the wrong spot. That did happen a couple times, but we made it through okay. Next slide. At Norfolk International Terminals, we really have, I consider 2 different terminals, but we call it one. There's NIT North and NIT South, and in the middle, there's that central rail yard. We did a huge expansion at NIT South. Next slide, please. And what that expansion essentially did was took the model of operating at VIG and brought it over to NIT. And this included those same automatic stacking cranes. And so we increased our volume to 1.2 million TEU containers, at South NIT. Through this, we've added 2 new ship-to-shore cranes very recently and have ordered 2 additional ones. So this project was very recently completed. Just getting those last 2 cranes commissioned right now. Hopefully they will be ready at the beginning of the year to take their first boxes off the vessel. Next slide. And this one is currently the big project ongoing right now. It's the deepening and widening of our the Norfolk Harbor channels, and we're doing this in partnership with the Army Corps of Engineers. Next slide. The project is a multi-phased, and it's intended to get us to that 55-foot depth, as well as provide 2 locations for wideners where vessels can meet each other, ultra-large container vessels can meet each other and maintain that 2-way traffic. Dredging began in 2019, and it is a cost-share project with the federal government. Next slide. What makes this important is I like to think about this as in terms of building a network. And so a lot of times you might think, okay, ports compete with each other. Of course we do commercially, but from an engineering and infrastructure standpoint, it really is about building a network on the East Coast. And so while we're currently at 50 feet and are going to 55 feet, it would make us the deepest port on the East Coast. There's other ports there like New York, New Jersey, Baltimore, Miami, some others that are also at 50 foot or going to 50 feet now. The difference is that those ports have a tidal range that we don't have. And so for us going to 55 feet is partially because the need to handle the tide swings or to have the extra couple feet of draft that the other ports have off of tide swings. So, we want to have a resilient set of infrastructure such that if something happens in New York, a snowstorm, fog, they can still get to Virginia with the cargo that they have. And this is something that regularly happens. Next slide, please. What's interesting about the project is we completed the GRR, the reevaluation report, 6 months ahead of schedule. It started in 2015, finished up in 2018. It got a really strong endorsement from Army Corps General that said, hey, we're standing by ready to begin construction. We took that to heart, completed design in 2019, and construction started in December of 2019. It's started over a year ahead of schedule. We're maintaining that and anticipating early finishes on this first segment that we're working on now. Next slide. Touch a little bit on our inland port. In 2018, we received a $26.5 million federal grant project aimed to double our rail capacity at the inland port. Part of the project is also building a new highway bridge separation project, grade separation outside the gate that will keep the roads open for commuters. So this project is now underway. We finally got our agreements in place and are about halfway through design and should be going into construction towards the end of 2021. Next slide. The Central Rail Yard expansion project, it's a combination of 2 grant awards, one from the Port Infrastructure Grant and one from the Rail Enhancement Fund, around a total of $25 million in grants. Total projects valued at around $80 million. We'll add 12,000 working feet of track at the terminal. It'll bring that cantilever rail mounted gantry technology over to NIT. So we kind of know where we're headed with that, and hopefully can improve on our densification. Next slide. This is the concept that we're rolling with. It's located on top of old warehouses. Next slide, please. If you're familiar with NIT at all, you probably remember a bunch of warehouses right in the central part of the yard that dated back to 1918. Over a period of about 6 months, we took those down, prepared the land for this rail yard project. It's located just south of the Navy Firefighting School and HRBT's property on the strategic plan. Next slide. So those are kind of the large projects going on. And large projects are interesting. At a certain point, you start to think, okay, the larger projects don't really take up too much of my time. It's really everything else that does. And so large projects, you have these multiple stakeholders. You are coordinating lots on the early end of it to get into construction, but there's still everything else. There's other projects ongoing. There's the potential for wind opportunities here, wharf extensions, utility repairs, retooling your existing facilities for the next thing, and fixing the broken things. Those kind of things take up a large portion of my time, and that's great because it keeps life interesting, keeps the day moving at a fast pace. And so over the next 6 years, we're projected to spend about $1 billion in capital outlay on these kinds of things like retooling the existing facilities, replacement of your existing waterfront infrastructure, fixing things that are broken. And so we've invested about $1 billion and got another $1 billion to go. So that's interesting. Next slide. So kind of, Paul, to your question before, there's always something that keeps going and going and going. And we have a event on February 10th to kind of brief the next set of RFPs, the next set of projects coming out. It's a workshop for vendors. This year it will be virtual given the current posture of the world. Normally it's in person. It's a pretty good thing to go walk around. I see some folks here that are participating that have attended that before. So I would encourage you to check our website for updates on that event as it comes out. Sometime it'll be on February 10th. Usually it's from about 8 to 2.
Okay, Zach, thanks a lot. If you could, when that event has more information and registration, please make sure you share that with me or any of the SAME officers so we can get that out on our website too. That would be super appreciated because those are the great opportunities out there. And yeah, you've got your hands full, whether it's the big projects or the smaller projects, you've got your hands full. Yet we have a solution of firms that are all the way from the big firms all the way to small woman-owned and service-disabled firms that are standing by to help you. Okay, so again, with the theme of me being the worst moderator ever, I've actually lost my connection twice, and with that, I've lost my questions. So if anybody else is like looking at the questions, I'd be appreciate if Leanne, you could bring that up. But
yeah, here I am.
Thanks. I'd like to reserve the first question for myself because I never did get a good answer to this one. Many of you know I cut my teeth on sea level rise when I first retired out of the Army. And I noticed, Martha, on your slide, you are excavating nearly 1 million cubic yards of excavated material. Knowing that Hampton Roads is sinking and we're rising, the sea is rising, will that material be used to counter sea level rise, or will it be repurposed back in the project? Any answer is fine, as long as you're not taking it out of here and dumping it off the continental shelf.
Yes, well, actually, bored tunnel excavation cannot go in the ocean. When you do an immersed tube tunnel, you can put it in ocean disposal, but the contractor is currently looking at various options and exploring possibilities for beneficial reuse. So more to come on that front. That
is the best answer I've heard today. And ODU has the Institution for Coastal Adaptation and Resilience, ICAR, that can definitely help you out with the planning of that beneficial use. It would be a sin. When I was the Corps commander, I said not one more cup of fill goes off the continental shelf. So I really like that answer. Leanne, do you still have the questions from the group?
I do. So a question from Wade Gazelle is, any lessons learned from the Seattle tunnel?
That has been one of the great references for us, because there are so few bored roadway tunnels in the US. Only Miami and Seattle have been completed to date. And the Seattle tunnel was a larger diameter. We learned from that one to specify additional instrumentation in the machine. One of the challenges of that project was understanding what the machine was thinking at various points along its path, and greater attention or knowledge of how the machine was doing might have enabled it to keep going rather than reaching the point where it had to stop. So this machine will have additional instrumentation for engineers to read along the way to help prevent the stoppage of the Seattle tunnel that was experienced out there. We recognize that as a point of comparison, in Seattle, it was possible to dig a shaft from the surface and repair the machine in situ. Here we're going under a channel. That won't be possible. So we need to have additional resiliency or robustness in the machine. We specified, for instance, in the contract requirements that all major components of the machine would need to be replaceable from inside, since it's not possible to come in from the top and replace them from the outside. So yes, certainly lessons learned there. And we actually went to Seattle, met with the project team there to understand what can we learn from that and bring back to incorporate into this project.
Leanne, is there
great? Next question.
Oh, thanks.
Yep. Who gets to name the TBMs?
Hampton Roads middle school students. Makes me want to be a middle schooler, because then I could put in a vote, but they wouldn't let me cast an option here. One thing, though, that's interesting historically is the instructions that were given to the middle schoolers were to consider names that had local or regional or historic significance, but traditionally TBMs have female names, and that goes back to the history of European tunnel mining, when St. Barbara was a patron saint of tunneling and miners and underground work, as well as military engineers, things that go boom, because originally mining was done by drill and blast, by explosives, and so that was the consideration, with St. Barbara being the patron saint of military engineers, miners, people who dealt with explosives. So that, as you saw from that list of TBM names, almost all of these machines end up having female names.
Leanne, there's a port question up in the chat.
Oh, well, there's one more tunnel question. Are the tunnels going to be straight state funding or P3?
We evaluated the P3 delivery option early on in the project development, and because there was enough public funding available, we did not go the P3 route, but this is straight state, regional, and a little bit of federal funding that will be delivered this project as a design build.
Okay, Leanne, thanks. I'll take it back. The next question is for Zach. Are there any plans to optimize North NIT, Norfolk International Terminal, similar to South Norfolk International Terminal optimization project?
The short answer is yes. Our master plans include building out North NIT in the same manner that South NIT was done prior to work at future crane island loading terminal. There's some caveats to that, mainly around timing, depending on what you need when you need it. And then, of course, some ongoing clearance issues, of course, with ships getting bigger, bigger cranes at North NIT with a conventional crane wouldn't necessarily be possible given the flight envelopes at Chambers Field. And so there's some technical problems involved with optimizing North NIT that have to be resolved, most likely with low profile cranes and warp strengthening prior to densification and RMGs at North NIT. But all of that is under consideration and development.
All right. Are there any other questions for the group? Like an aerospace question, like who's going to join David on the way to Mars? I think we joke with David a bit, but for the group, please also understand a big part of his presentation is about autonomy and autonomous systems. And I'm excited the way that he is looking at using drones to inspect our offshore wind turbines and underwater too. I'm excited how he's integrating with transportation. The tunnel project is just cool too. And Zach, I think you're right. The port, there's always something going on there. But just so you know, my friend, that 2015 document that got this started, it has my wet signature on it. So the reason why I'm sticking around is so it gets done. So I'll be breathing down your neck, okay?
I won't let you down.
Oh, please don't. Okay. Any other questions for the group before, I don't know, maybe something comes to mind? Leanne, what do you think? I'll turn it back over to you.
Yeah, so, well, first of all, thank you to you just downplay yourself so much, but you are an excellent moderator, and with everything going on, thank you for stepping in and doing everything that you've done. I really appreciate it. I really couldn't do this without you and your great connection. So thank you for that. And thank you, for all three of you for being excellent panelists and giving us such great information about, aspects that we don't always think about as SAME. People consider SAME really military, but that's not it. We're all about resilience in general and our national security on all fronts. And so all of these things, whether they tie directly to the military or not, are absolutely essential to what SAME is doing and what our community is doing. So thank you again. We are going to switch over to happy hour time. So I will pull up a trivia screen here shortly and give everybody a few minutes to go get a beverage because, you can't have trivia without a beverage in your hands. So pick whatever your favorite beverage is. But before I do that, I just wanted to let you guys know that, as your regional vice president, I'm very thankful to be part of the Middle Atlantic region and to be able to help pull together events like this and pull